models this situation. If your piggy bank contains $25 and $1.50 is added each day, we have to write an algebraic expression. Okay, this is just like an example from yesterday. Hopefully you remember, $1.50 is added and we start with $25. So if we started with $25, that doesn't mean anything is going to change. That's just going to stay the same. That's going to be a constant term, so it's not going to have a variable. But then it says $1.50 is added each day. Since there is a value, like a day value or a week value, you need to add a variable to that in case I wanted to ask you what or how much money would you have after 7 days. It's easily determined. Since we have a variable with it, x would be number of days, so our algebraic expression is 25 plus 1.5x. We're moving right along. 1.4 is solving equations. We aren't moving too slow or too quick because we're just reviewing from stuff you have learned in the previous years. So, some objectives of today are to be able to solve equations. These are simple 1 to 2, maybe 3-step equations, and be able to solve problems by actually writing out the equation yourself. The vocab word for today is equation. It's a statement that two expressions are equal. So you need to have an equal to sign. So say we have 2x plus 3, and that's going to equal 13. And this would be an equation because it has that equal to sign. Some of the properties of equality, and you should have learned these in geometry as well. You use them for writing your proofs. The first one is reflexive. So notice how you have a equal to a. That means you're going to have your same number, same variable, anything equal to itself. Symmetric is kind of like a mirror. If you notice you have a equals b, then b is also going to equal a because it's the same thing. Transitive property, if you have a equal to b and b equal to c, then we can say a is equal to c. If you notice, the last part of the first equation and the first part of the second one are the same. So if we cross those out, we'll get our final result, a equals c. And then substitution. If a equals b, then you're going to replace a with b and vice versa. So anytime you see a, you can replace it with b, or anytime you see b, you can replace it with a. These should be self-explanatory. Don't necessarily need to write these down. Just know what you're doing to one side, you'll also have to do to the other side. In previous lessons, I asked you, what is the opposite of addition? What is the opposite of subtraction? Opposite of multiplication, division, and square. So you need to remember those when we're solving equations. If we have a plus on one side, how do we get that to the other side? So our first one, very simple, x plus 4 equals negative 12. If it helps you, draw your line down your equal to sign. And we need to solve for x. That means we need to get x by itself, and it's being added by 4. So the opposite of addition is subtraction. So we subtract 4 to get rid of it. But if we do that on the left, we also have to do that on the right. We subtract 4 on the right-hand side. Draw our line here. Plus 4 minus 4, those cancel. That was our goal. We're left with x equals, and when you add up negative numbers, just ignore the negative sign. Add them up normally, 12 plus 4, and just put a negative sign out front. So we have negative 16. This may seem very simple and easy, but there are just some things we need to review because they do get a lot harder. Alright, so the first one, negative 27 plus 6y equals 3 parentheses y minus 3. Go ahead and work this one out. Hopefully you notice with the parentheses on the right hand side of the equation that you need to distribute through. So go ahead and pause, work both of these out, and figure out what you get for y in the first equation and x in the second. For the first one, you should get y equals 6. And for the second one, you should get x equals negative 1. This next example, we're talking about flower carpets. It's incorporate hundreds of thousands of brightly colored flowers, as well as grass, tree bark, and sometimes fountains to form intricate designs and motifs. The flower carpet shown here from Grand Place in Brussels, Belgium, has a perimeter of 200 meters. What are the dimensions of the flower carpet? Okay, so if you notice along the bottom here, it is x and 3x. And we know that the perimeter is 200 meters. So hopefully you remember perimeter means you add up all your sides. So if we need to write our algebraic expression, we know our perimeter is 200, and we got to add up all of our sides. We know that one side is x, which means the other side is x, so that's 2x. Add this side, we're going to add a 3x to it, so that's 7x. Add a side over here and we get 10x. You then need to solve this out for x, come back and tell me what the dimensions of this carpet are. Sorry, you should get 8x, not 10. Losing my mind. 8x. So when you solve for x, you should get 25, which makes your dimensions 25 by 75 meters. Next, to determine if these equations are always, sometimes, or never true, we have to solve them out. So draw your line down the middle. And my first suggestion would be to combine like terms on one side. So if I see 11 and negative 7, that's going to combine to 4 plus, and we still have 3x. Then on the right hand side, we also have like terms, 6x and negative 3x. So bring down your 5, combine your like terms, and we get plus 3x. And then we can stop here. Because if you notice, we have 3x and 3x, the same term on both sides. So that means if we got rid of those, we would have 4 equal to 5, and that will never be true. So the first one is never. So go ahead, work through the second one, and determine if it is always, sometimes, or never true. After you combine like terms, you should get 4x plus 5 equal to 4x plus 5, which is always going to be true, because it's the same expression on both sides. This last example, we have to, what is f in terms of C? So if we look at our equation, this gives us, this is Celsius and Fahrenheit, and C equals 5/9 F minus 32. My first suggestion would be to, instead of multiplying this 5/9 through, I would take it to the other side by multiplying both sides by 9/5, because when you multiply a fraction by the reciprocal, we get 1. So if we have 5/9 and we multiply by 9/5, we will get 1, but I'll show you how. So when you multiply fractions together and there's no equal to sign, you multiply the top. So 5 times 9 is 45. And then on the bottom, we have 9 times 5, which is also 45. And 45 divided by 45 is 1. So to get rid of this 5/9 here, multiply both sides by 9/5. So we will have 9/5 C equals, and we got rid of this, we're left with F minus 32. So our last step is to get F by itself, which you need to add 32 to both sides. So what is F in terms of C? You should get F equals 9/5 C plus 32. This is the end of 1.4. Here is your homework. We will be working on it in class tomorrow.